So we're going to be solving exponentials with logs. So some of these might look very familiar, but we're going to have to come up with a new technique to solve some that doesn't work with what we've done in the past. So for instance, this is a problem that we have done before. So if we have 5 to the n plus 10 equals 25, I need to find a common base. Well, I know that I can rewrite 25 as 5 squared. So now that my bases match, I know that my exponents have to match. Therefore, n plus 10 has to equal 2, which means that n equals -8. So that's the type where we can actually create a common base and we know the exponents match. Now, the problem is that if we can't come up with a common base, so if a common base is not possible, what we do is we take the log of both sides. It's kind of like how addition and subtraction are inverses, multiplication and division are inverses, squares and square roots. Well, an exponent and a log end up helping to undo each other. So for this problem, we have 2 to the x power equals 61. 61 isn't a multiple of 2, so we can't make a common base. So what we're going to do is we're going to take the log of both sides of our equation. So we're going to take the log of both sides of our equation. Now, if you remember the product property, if you have an exponent, it can come outside of the log and be multiplied in front. So I'm going to take my exponent and I'm going to put it out front. So it's x log 2 equals log of 61. Now notice that the log that I'm using is the common log, which means the base is a 10. But when the base is a 10, we don't actually have to write the 10 down there, so we just use the 10. What's also really nice is that button is actually on your calculator. Now, from here, if I wanted to get x by itself, right now it's being multiplied by the log of 2. So I'm going to divide both sides by the log of 2, which gets me that x equals the log of 61 over the log of 2. So if you take in your calculator the log of 61, and I'm going to show you what I'm talking about. So if you have a normal calculator or an iPhone calculator, the button you're looking for says log. Some of them will say log base 10, some of them don't. So the way that you do it with at least an iPad or an iPhone is if I want to figure out the log of 61, I'm first going to put 61 into my calculator, and then I'm going to hit the log button. And I'm going to get about 1.785. If you have a normal calculator, give it a try. You might have to do the other way around, especially if when you click the log button, if it brings up parentheses, you're going to click the log button and then the number itself. So then if I take the log of 2, so I'm going to hit 2 with that log button, I'm going to get 0.301. And if I divide those two, 1.785, they're of course rounded right now, divided by 3.01, I'm going to get about 5.93. So that's how you find the logs in your calculator. So now we have solved for x. We didn't have to find a common base because we were able to move the exponent outside by taking the log of both sides. So problem number 2. First of all, we do not have the exponential part of the equation by itself. So if you have that, you first need to get it by itself. So there's a -5, so I'm going to add 5 to both sides. So we have 4 to the 3x equals 8. Now for this one, we could come up with a common base, but I'm just going to be lazy and I'm not gonna. So I'm going to take the log of both sides of my equation. I'm just going to be lazy again and move the 8 over. So I'm going to take the log of both sides. Now my exponent is going to go out front. So I have 3x times the log of 4 equals the log of 8. So if I want to start getting my x by itself, I'm going to have to eliminate the log of 4 and the 3. So I could do both of them together. I'm going to do one at a time right now. I'm going to go divide both sides by the log of 4. So now I have 3x equals, and it's about 1.5. I believe it is 1.5. If I divide both sides by 3, then x equals 0.5. And the last problem. So we have negative 2 times 5 to the x plus 7 equals negative 63. So this exponential part is not by itself at all. So it's like solving an equation. First, I'm going to subtract 7 from both sides, and I'm going to get negative 2 times 5 to the x power equals negative 70. And then I'm going to divide both sides by negative 2 because my goal is to get that 5 to the x power all by itself. So now it is by itself, and it equals 35. If I then take the log of both sides, that will get my exponent, my variable, out of the exponent. So we have x log 5 equals the log of 35. And then to get x by itself, I need to divide both sides by the log of 5. And if I were to put the log of 35 divided by the log of 5 into my calculator, I would get about 2.2091. Okay, we'll be practicing this on Wednesday. Make sure you get all of your other work done. Anything that is missing or is finished, put it into the blue box at the corner of my desk so I can get you credit. Have a great day.